Good morning, this is Mr. Precella, and today we're going to review fractions. We're going to review simplifying fractions and adding, subtracting, multiplying, and dividing fractions in this short video here. To begin with, let's start off reducing fractions. You might see instructions that say simplify, or it might say reduce. Let's start off with this one. 16 over 24. Well, to reduce a fraction, we want to rewrite it so that there's no common factors between the numerator and the denominator. The numerator is the number on top and the denominator is the number on the bottom. The fastest way to do this is to ask yourself, what's the biggest number that divides into both 16 and 24? And if you think, okay, what about 8? Does 8 divide into both of these? 16 divided by 8 would be a 2. 24 divided by 8 would be a 3. So 2 over 3 is the simplified form of that fraction. Notice there's no number other than 1 that divides into both 2 and 3, so you know that this thing is simplified. Now, you might recall that with simplifying fractions, you don't always have to do it in one step. If you can't figure out the biggest number, you can always just start, make it several steps. Divide both of these numbers by 2. That would be an 8 over 12. Well, it's still not done because you can divide both of them by 2 again. So a 4 over 6. And then finally, divide both of them by 2. That'll still get you the 2/3. The important thing is to get the simplified form. If you have to take a couple of steps, and that might be especially true if the numbers were real large, then that's okay. So this is called simplifying a fraction. Let's simplify this one. 24 over 40. Let's see, right off I think, what about a 4? 4 divides into both of these, but a bigger number does 8. Just like up here, I guess 8 divides into both of these. 24 divided by 8 would be a 3. 40 divided by 8 would be a 5. So 3 over 5 is the reduced form. Now, when the numerator is smaller than the denominator, that's called a proper fraction. But here's an improper fraction. 350 divided by, or over, 50. Notice how I said divided by. Those fraction bars represent division. 350 divided by 350 divided by 50 is the same thing as reducing the fraction 350 over 50. 350 divided by 50, that's just a whole number, 7. Notice we don't need to write it as 7 over 1. Just think of it as division. 350 divided by 50 is 7. And here's one for y'all to try. What about this one? 180 divided by, or over, however you want to call it, 20. 180 over 20. 180 divided by 20, either way. Is that a 9? Yeah. Okay. Let's see. Let's do one with some bigger numbers. How about this one? Let's try to reduce 500 over 240. Well, you know what? Why don't we break this up into a few steps? Like, we could start off by dividing above and below by 10. 50 divided by 10, 500 divided by 10 would be a 50. 240 divided by 10 would be a 24. And I think we can now simplify it some more. What about a 2? Does 2 divide into both of these? If we divide both of these by 2, that would give a 25 on top and a 12 on the bottom. Notice that's an improper fraction. Some of you might remember writing improper fractions as mixed numbers. In algebra, generally, we leave them as improper fractions. Also, are there any numbers that, can I reduce it any further? Well, the only thing other than 1 and 25 that divides into 25 is a 5, and it certainly doesn't divide into 12. So, that is our reduced fraction, 25 over 12. Now, let's review adding and subtracting fractions. To add and subtract fractions, I bet y'all remember this phrase, you got to always have a common denominator. Remember, denominator is the number on the bottom. Denominator starts with the letter D, just like down. So that's how you can remember it. Okay. Let's see. How about adding this one? 15 over 16 plus 11 over 16. We're going to add these two fractions, and always, if it can be simplified, you always want to reduce it, okay? Well, if the two fractions have the same number on the bottom, then you just keep that denominator and add the numerators. 15 plus 11, that would be 26. And is 26 over 16 the answer that we're going to, if you're using My Math Lab or Pearson My Lab, is that what you would type in? Well, no. You could reduce this by dividing both of these numbers by what? Would 2 do it? If I divide it above and below by 2, I would get a 13 on top and an 8 on the bottom. There's no other number that divides into both of those other than 1. So 13 over 8 is our answer there. Okay, let's do another one. Here's one. 5 over 6 plus 11 over 18. 5 over 6 plus 11 over 18. Notice, no common denominator. So we need to rewrite this problem so that we have the same number here and here. In order to do that, you have to find the smallest common multiple. Like if we think of the multiples of 6, what are the multiples of 6? Multiples of 6. 6 times 1, 6 times 2, 6 times 3, 6 times 4. I think we can stop as soon as we see 18. We can rewrite both of these fractions with an 18 as the denominator. Now this one over here already has an 18. But what about this first fraction? How do we write it with an 18 instead of a 6? Well, in order to get an 18 down here, I would need to multiply the bottom by 3. In order to keep these fractions equal, I better also multiply the top by 3. So we have 15 over 18 plus 11 over 18. Now that we have the same denominator, we can write that as an 18 on the bottom. Add the 15 and 11 to get 26. And you can tell by my equal sign, we can reduce it. What can we divide both of those numbers by? A 2. So we have 26 divided by 2, 13. 18 divided by 2, 9. So 13 over 9 would be our answer in reduced form. We always reduce our fractions. Notice how you have to always have a common denominator. Okay? This one started with a 6, so we need to rewrite it so that we have the same denominator. Okay? Here's another one for us to do. 3 over 14 plus 5 over 6. Well, I don't think we're going to get as lucky as we did on the other one. I don't think the bigger number is going to be a multiple of 6. Let's see. What are the multiples of 6? Well, I've already started them up here. 6, 12, 18, 24. Then let's add a few more. 6 times 5 would be 30. 6 times 6, 36. 6 times 7, 42. 6 times 8, 48. Let's see if that's enough if we look at the multiples of 14. Now, you might want a little calculator to help you with these. 14 times 1 is 14. 14 times 2 is 28. 14 times 3 is 42. And that's it. Notice 42 is a multiple of both 14 and 6. So we need to rewrite both of these fractions with the denominator of 42. How do we do that? Well, 14 goes into 42 3 times. 3 times 14 would be 42. Multiply the top by 3 also. 3 times 3, 9. Y'all see how I did that? 14 goes into 42 3 times. 3 times 3 is 9. Let's do the same thing here. 6 goes into 42 7 times. 5 times 7, 35. Okay. Once again, 6 goes into 42 7 times. 5 times 7, 42. Logically, what we're doing is we're multiplying both of these fractions by, both the numerator and denominator by 7 over 7. A number over itself is 1, so we're not changing it. We're just making the numbers bigger, the numerator and denominator, but we're not changing the value of the fractions. Now that we have two fractions with the same denominator, we write that denominator down and then add. 9 plus 35 is 44. Well, we can reduce that by dividing each one of these numbers by what? 2 again? If you have two even numbers, you can always divide by 2. If I divide both of these by 2, I'd have a 44 over 2. 44 divided by 2, which is 22. 42 divided by 2 is a 21. And there's nothing else that divides evenly into 22 and 21. Let me say that again. 44 divided by 2 is 22. 42 divided by 2 is 21. Okay? So 3 over 14 plus 5 over 6 is 22 over 21. Let's subtract. How about this one? Here's a subtraction. 27 over 7 minus 6 over 7. Well, we'll do one first. Notice, when you're subtracting, you got to have that common denominator. Here we already have a common denominator. So just write down the common denominator once. 27 minus 26 is a 21. And that can be reduced, can't it? 21 over 7. Think of it as division. And that falls straight from the multiplication tables. 3. If you're going to be taking any sort of math course, you need to make sure you have those multiplication tables memorized. Even if you can use a calculator for little fast manipulations. Imagine if every time, okay, you're going to multiply by 3, and you don't know 3 times 3 is 9, and you're having to punch that into a calculator. Let me tell you, it'll take you 10 times longer to get the assignments done than you should. So if you don't have your multiplication tables memorized, at least up to 10 times 10. Okay, if you don't have your 11s or 12s memorized, well, okay. There was a while back when Texas public schools ended the multiplication tables at 10 times 10, but then they've gone back to 12 times 12. If you need a multiplication chart, just Google it, multiplication tables, and there's 1,000,001 of the little tables, and just sort of carry it around with you. If it's been a while since you've done a lot of multiplying, you might need to review those. It'll be worth your time, okay? Let's see. Now let's do one where there's not a common denominator. How about this one? 5 over 18 minus 1 over 27. I'm not sure, or you might not recognize the common denominator right off. So let's just start off with multiples. By multiples, I mean I'm doing multiples of 18. And here you might have a little calculator helping you with this if necessary. 18 times 1 is 18. 18 times 2 is, 36. 18 times 3, 54. I'm stopping right there because what are the multiples of 27? 1 times 27 is 27. 2 times 27 is 54. I spotted that was the common multiple, smallest common multiple right there, 54. So we need to rewrite each of these fractions with a 54 as its denominator. Okay, so 18 goes into 54 3 times. 5 times 3, 15. Okay. 18 times 3 is 54. 5 times 3 is 54. Notice in algebra, we usually use a little dot for multiplication instead of an X. Okay, and that's what I'm using there, because we'll be using X's for variables in algebra. Now, what about this? What do I have to multiply 27 by to get 54? Well, a 2. 27 goes into 54 2 times. 1 times 2 is 2. Are we going to get one that we have to reduce here? Let's see. Write down the 54. Then 15 minus 2 is 13. Does 13 divide evenly into 54? Well, no. Okay. So we leave it as 13 over 54. When you're adding and subtracting fractions, you've got to have that common denominator. Now, how does that differ when multiplying fractions? Oh, let's see. Sorry for that break there. I thought that my camera had the recording had frozen up. But let's see about multiplying fractions. This is one of those things where sort of odd. Multiplying is actually easier than adding and subtracting. With multiplying fractions, you don't have to get a common denominator. You just multiply straight across. Multiply, ooh, my pen is going dry, and divide fractions. So let's start off with this one. Here's a good one. 2 over 9 times 4 over 11. 2 over 9 times 4 over 11. To multiply fractions, you multiply straight across. 2 times 4 is 8. 9 times 11 is 99. Like always, we ask ourselves, can we reduce the fraction? And here we cannot. There's no number that divides both into 8 and 99 except for a 1. So to multiply fractions, you multiply straight across. How about this one? These little squiggly lines are where I'm separating and starting a new problem. 20 over 3, notice you don't have to worry about any common denominator when multiplying, times 15 over 14. If you want, you can multiply straight across and then reduce the fraction. Okay? 20 over 15 would be a 300. Excuse me, 20 times 15 would be a 300. 3 times 14 would be 42. But what I want to do here is show something that you can do with fractions to get slightly smaller numbers. When you're multiplying fractions, only when you're multiplying, not when you're adding or subtracting. When you're multiplying, you can do this cross-canceling. Do y'all remember that? Look at the 3 and 15. What number divides into both of those? Well, a 3. So this 3, if we divide by 3, that would be a 1. This 15 divided by 3 would be a 5. Now let's try with the 20 and the 14. What number divides into both 20 and 14? Well, 2. 20 divided by 2 would be a 10. 14 divided by 2 is a 7. And I know this is messy, so let me rewrite all of this. Let's see. We would have a 10 over 1 times 5 over 7. Now, just multiply straight across. Now, I think you're going to get much smaller numbers there. 10 times 5 would be 50. 1 times 7 is 7. Do I need to reduce this? Is there any way I can reduce 50 over 7? Well, no. So 50 over 7 is our answer there. Now, what about dividing fractions? Remember, though, with multiplication, you can do this cross multiply. Okay? And if you don't like that, again, you could have just multiplied straight across. You would have had a 300 over 42. And you can think, okay, divide above and below by 6. That would get you the 50 over 7. Okay? But most students prefer working with the smaller numbers rather than reducing the fractions with the bigger numbers. That's why I always try to cross-cancel when I can do that, or when there is something to cross-cancel. If you're wondering, well, why didn't I do that here? There was nothing to... No number other than 1 goes into 4 and 9. No number other than 1 goes into 2 and 11. Now, what about division? How do we divide fractions? So, here's the division problem. 14. No, it's not. Let's use this one instead. 7 over 6 divided by 3 over 5. Do y'all remember how to divide fractions? Well, if you can multiply fractions, you can divide them. What you do is you're going to rewrite this problem as multiplication by rewrite the first fraction, 7 over 6. All of my pens are drying up. I've used them too much. Now you're going to rewrite the division as times. This is one of those times dots. And then you're going to take the reciprocal of this fraction. By reciprocal, or to take the reciprocal, you flip it. Okay? So you change the division to multiplication. And then you change the 3 over 5 to 5 over 3. You flip it. Okay? That's how you do all fraction multiplication. You rewrite it as division. Excuse me. That's how you do all fraction division. You rewrite it as multiplication by flipping the second fraction. Okay? So write it 7 over 6 times 5 over 3. First thing I look to do is, okay, can I cross-cancel anything? No. So just multiply straight across. 7 times 5 is 35. 6 times 3 is 18. Is there any number that divides evenly into both of them? Well, no. 5 and 7 divide into 35, but not 18. Notice, if you don't know the multiplication tables, you don't know that. How do you figure out whether it's reduced? So once again, if you're rusty on those multiplication tables, I highly recommend that you give it a try. I mean, that you find your multiplication tables and review them. Okay, how about one last problem? This will be good. 3 over 2 divided by just the whole number 15. You might be thinking, well, wait a minute. How are we going to flip that? Well, you can always think of 15 as 15 over 1. Okay? You can always take a whole number and write it as a fraction by putting it over 1. Then we'd have 3 over 2. Change the division to multiplication. Flip the next fraction. And either multiply straight across, or is this one where I can do the cross canceling? Well, there's nothing to cross cancel with the 1 and 2, but right here, I could divide the 3 and the 15 both by 3 to get a 1 and a 5. Then when I multiply straight across, 1 times 1 is 1. 2 times 5 is 10. So 1 over 10 is our reduced form. Now, of course, if you just multiplied straight across, you would have gotten 3 over what? A 30? And could you have reduced that to 1 over 10? Well, sure. Divide them by 3 there, and you still get 1 over 10. Okay? But you always want your answer written in simplified form. Okay? So this is just my little short review of fractions. You'll be simplifying, adding, subtracting, multiplying fractions off and on through every math class you take. Okay? So thank you for watching, and have a good rest of your day.